Hello students, welcome to physics online classes. In the last class, we started discussing on atoms and nuclei. So we saw with the synopsis some numericals. Today, the continuation of that. So we can see directly we'll move to the problem. So the 23rd problem. The energy required to excite an electron in hydrogen atom to its first excited state. In general, we have the energy level En is equal to minus 13.6 divided by n square electron volt. So if it is a ground state, so n is equal to 1, so it is minus 13.6 divided by 1 square, that is minus 13.6 electron volt. Then excited state is n is equal to 2, so minus 13.6 divided by 2 square, so you'll be getting minus 3.4 electron volt. So E2 minus E1 is equal to minus 3.4 minus of minus plus 13.6. So you'll be getting 10.2 electron volt. So option 2. I hope you're clear with that. An electron in hydrogen atom jumps from second excited state to the first excited state, and then from first excited state to ground state. Let the ratio of wavelength, momentum, and energy of photons emitted in these two cases be A, B, and C respectively. So, in general, we can write it as E is proportional to 1 by lambda and P is proportional to E. So how you are going to say from this formula E is equal to Hc by lambda. So from that you can say E is proportional to lambda, inversely proportional to lambda. So directly proportional to lambda. So from this you can also write it as E is proportional to 1 by n square. Further you can say from this relations you can say B is equal to C, A is equal to 1 by B. B is equal to C and A is equal to 1 by B. Okay. From this, when you solve this, so from this you can write it as from whatever this relation B is equal to C. Why? Because the ratio of wavelength, momentum, and energy of the photon in these two cases is A, B, C. That is, lambda is equal to A, right? Momentum is equal to B, and energy is equal to C. Okay, so from that relation, and also from the relation E is proportional to 1 by n square. From this, you can write it as, so A is equal to 1 by C agat, or C is equal to 1 by A. C is equal to 1 by A. So option 1. Okay. Okay. I hope you are clear with that. Right. Next problem. If the radius of the nucleus of 8 Fermi, then the radius of the helium nucleus will be, you have the formula R is equal to R naught A to the power 1 by 3. So R1 by R2 is equal to A1 1 by 3 divided by A2 1 by 3. Okay. So it is 256 divided by 4 all to the power 1 by 3. Okay. If that's the case, then the cube root of 2 ಏನು ಬರುತ್ತೆ? ಸಾಲ್ವ್ ಮಾಡಿದ್ದೇನೆ. ಸೊ ಹೀಲಿಯಂ ಬಂದು R2, X ಅನ್ನೋದೇನು R1. So if you further solve that, so you'll be getting this is equal to 4 ಬರುತ್ತೆ. So ಆಗ R2 is equal to R1 by 4. R1 ಎಷ್ಟು 8 by 4. So it is 2 Fermi. Option 2. Right? Okay. Next, the acceleration of an electron in the first orbit of hydrogen atom is. So you have the formula, acceleration is equal to v square by r. V square by r. M v r is equal to nh by 2 pi. nh by 2 pi. So using these two relations, try ಮಾಡಿಲ್ಲ. Next problem ಇದು. The acceleration of an electron. From this further relation, you can write it as h square by m square into r cube. Okay. Next, the angular momentum. The angular momentum of an electron in the first orbit of lithium ion is. So you have L is equal to NH by 2 pi. So N is equal to 1 in the first orbit antadu. So it is H by 2 pi. So option 3. An electron in a hydrogen atom makes a transition from first excited to ground state. The equivalent current due to circulating electron. Equivalent current due to circulating electron. Okay, we have the formula I is equal to Q by T. Okay, so you can say T square is proportional to R cube is proportional to n to the power 6. So an electron in an hydrogen atom makes a transition from first excited state to the ground state. The equivalent circuit due to circulating electron. So in this relation you can write like this, and finally you can write I is proportional to 1 by n to the power 3. 1 by n to the power 3. So it increases 8 times. It increases 8 times. So if first excited potential of an hydrogen-like atom is V electron volt, then the ionization energy of this atom will be the first excited energy. So first excited energy is given as RHC. Okay, first excited energy RHC is 1 by 1 square minus 1 by 2 square. So when you solve this, RHC 3 by 4. So 3 by 4 RHC is equal to V electron volt. Again the energy. So RHC, that's nothing but ionization energy, is equal to 4V by 3 electron volt. So option C. In hydrogen, okay, that is about the. So you have to remember the ionization energy formula. Okay, in a hydrogen atom, following the Bohr's postulate, the product of linear momentum and angular momentum is directly proportional to n to the power x, where n is the orbit number, then x is. So you have the formula for the linear momentum. mv is proportional to 1 by n. Angular momentum mvr is directly proportional to n. So if you take the product of linear momentum and angular momentum, it is directly proportional to n to the power 0. So option 1. I hope you're clear. Right. An alpha particle of energy is 5 mega electron volt is scattered through 180 degree by a fixed uranium nucleus. The distance of the closest approach is. So distance of closest approach. Okay. So you have the formula. So R is equal to 1 by 4 pi epsilon ಗೆ 9 into 10 to the power 9 ಮಾಡಿದ್ದೀವಿ. Okay. Let's substitute that. R is equal to alpha particle ಅಲ್ವಾ, 2 into 1.6. So Z uranium ತಗೊಂಡಾಗ 92. ಅದೆಲ್ಲಾನು ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ZE the formula ಏನು, R is equal to 1 by 4 pi epsilon naught ZE to 2E divided by kinetic energy ಅಲ್ವಾ, E. ಓಕೆ, ಅಲ್ಲಿ ಆಲ್ರೆಡಿ ಕೊಟ್ಟಿದ್ದಾರಲ್ವಾ, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗಿ. 9 into 10 to the power 9 ಇದು. Z is 92 into 1.6 into 10 to the power minus 19. 2 into 1.6 into 10 to the power minus 19 whole divided by 5 into 10 to the power 6 into 1.6 into 10 to the power minus 19. ಈ ಸೆಟ್ಟು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಈಗ ಇದನ್ನು ಫರ್ದರ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ R ಹೇಳಿ. So atomic number of uranium is 92. Number of proton in alpha particle is 2. So ಅದು ಫಾರ್ಮುಲಾ ಈಗ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ, ಚೆಕ್ ಮಾಡಿ. ಸೊ ಏನಂದರೆ ಇಲ್ಲಿ ಫಾರ್ಮುಲ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ನಾವು ಮಾಡಿದ್ಮೇಲೆ ದ ಥಿಂಗ್ ಇಸ್ ಅಲ್ಲೆಲ್ಲ ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿರೋದು 10⁻ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, ಆನ್ಸರು ಸಮ್ ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂ ಇಂಟು 10⁻ಅಲ್ಲಿ ಇರುತ್ತೆ. ಆ 10⁻ನ ತಗೊಂತೀರ. So I hope you would have done this. It is 2.5 into 10⁻⁻12 centimeter. So ಅಲ್ಲಿ ನನಗೆ ಆಪ್ಷನ್ಸ್ ಇರೋದು 10⁻⁻12, 10⁻⁻10, 10⁻⁻8, 10⁻⁻15. So 10⁻⁻12 is the right answer. Next, which of the following lines of H atom ಅಂದ್ರೇನು hydrogen atom spectrum belongs to the Balmer series. So Balmer lies in the visible region. So the wavelength is about visible region is from 4000 Armstrong to 7000 Armstrong. So it will be lying between 4000 to 7000 andre. The right answer is option 3. Option 3. Two nuclei having their mass numbers in the ratio 1:3. The ratio of their nuclear density would be. So as they given here is, so A1 is to A2 is to 1:3. So R naught A1 whole to the power 1/1:3, R naught A2 1/3. This can be written as 1/1 to the power 1/3 is to 3 to the power 1/3. Okay, now you know that rho is equal to A divided by 4/3 pi r cube. Solve ಮಾಡಿದಾಗ rho A1 is to rho A2 is equal to 1 divided by 4/3 pi r naught cube into 1 cube is to 3 divided by 4/3 pi r naught cube 3 to the power 1/3 the whole cube ಅಂತ ಬರಿತೀವಿ. ರೇಷಿಯೋ ತಗೊಂಡಾಗ ಫೈನಲಿ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ 1:1 ಬರುತ್ತೆ. ಯಾಕಂದ್ರೆ ಅಲ್ಲಿ ಕ್ಯೂಬ್ ರೂಟ್ ಮತ್ತೆ ಕ್ಯೂಬ್ ಏನಿದೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಕ್ಯಾನ್ಸಲ್ ಆದಾಗ ಕಂಪ್ಲೀಟ್ ಟರ್ಮ್ಸ್ ವಿಲ್ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ಡ್. ಆದರೆ ಇಟ್ ಈಸ್ 1:1. The transition from the state n is equal to 4 to n is equal to 3 in a hydrogen-like atom results in UV radiation. So infrared radiation will be obtained in the transition from. So it is given that transition from the state n is equal to 4 to n is equal to 3 in a hydrogen-like atom result in UV radiation. So 4 to higher to lower bandaga UV radiation. For the infrared radiation, the energy gap should be less. So the only option is 5 to 4. So infrared radiation will obtain in the transition from 5 to 4. Okay. So as you all know that the different energy levels, so different energy levels, so n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. So the energy is in increasing. The energy increases. So infrared region will obtain in the transition from 5 to 5 to 4. Okay. So two hydrogen atoms are in excited state with electrons residing in n is equal to 2. First one is moving towards the left and emits an photon of energy E1 towards right. Second energy is moving towards the left with the same speed and emits an left photon of energy E2 towards left. Taking recoil of nucleus into account during the emission process. So you can say that there is an hydrogen, atom. Okay, so the energy whatever you are going to say, that is E1. Next case, if it is moving this direction, one is moving right side, the other one is moving left, one is moving. So at that particular point, E2 will be there. Okay. In case 1, kinetic energy of the hydrogen atom increases due to recoil, whereas here it is going to decrease. So you can say E2 is greater than E1. So if E2 is greater than E1 andre E1 is less than E2. E1 is less than E2. I hope you are clear with that. So in a nuclear reactor, the function of the moderator is slow down neutrons. Slow down neutrons. 1 mega electron volt energy is equal to 1.6 into 10 to the power minus into the power 6 ಅಂದ್ರೆ 1 ಮೆಗಾ ಅಂದ್ರೆ 10 to the power 6. ಎಲೆಕ್ಟ್ರಾನ್ ಅಂದ್ರೆ 1.6 into 10 to the power minus 19. So minus 19 plus 6. So it is 1.6 into 10 to the power minus 13. So option C. In the uranium radioactive series, the initial nucleus and final nucleus When the uranium nucleus decays to lead, the number of alpha particles will be emitted will be. So it's based on the theory based question. So option 4. So in the uranium radioactive series, the initial nucleus is uranium 23892 and final nucleus is 2 20582. When the uranium nucleus decays to lead, the number of alpha particles emitted will be 8. The activity of radioactive sample is 1.6 curie and its half-life is 2.5 days. Its activity after 10 days will be. So you have number of half-lives is equal to, so 10 divided by 2.5 ಮಾಡ್ತೀರಾ. So you have the activity. Activity is given as A is equal to A naught by 2 to the power n. So A naught is 1.6 divided by, so n andre number of leaves, half lives is nothing but 10 divided by 2.5, so it is 100 divided by 25 is 4. So 1.6 divided by 2 to the power 4. So 1 divided by 10 ಆಗುತ್ತಾ? It is fine. ಯಾಕಂದ್ರೆ 16 divided by 10 into 16. So it is 1 divided by 10 is 0.1 curie. Option 3. In a mean life of radioactivity sample, about 2 by 3 of the substance disintegrate. Half-life of an element is 30 days. How much part will remain after 90 days? So 90 divided by 30 is 3. So number of leaves will n divided by 3. So n divided by 3 andre, so n is equal to n naught by 2 to the power n. So 2 to the power n ಇವಾಗೇನಾಯ್ತು 3. So 3 ಅಂದ್ರೆ 1 by 8 ಆಗುತ್ತೆ. You have the formula. Number of half-lives ನೋಡ್ಕೊಳ್ಳಿ ಇದನ್ನ. ಅಂದ್ರೆ n is equal to 90 divided by 30. So n is equal to 3. ಈಗ n is equal to n naught by 2 to the power n. So n naught by 2 to the power 3. 2 to the 4, 4 to the 8. So it is 1 by 8 part. 1 by 8 part. Okay. Next, a nucleus emits an alpha particle. The resultant nucleus emits a beta plus particle. The respective atomic and mass number of the final nucleus will be. It is Z is equal to 3, A is equal to 4. Z is equal to 3. A is equal to 4. Direct. Next, what fraction of a radioactive material will get disintegrated in a period of two half-lives? In a period of two half-lives. 1/4. Correct? Direct no. So 1/4. Fusion reaction occurs at the temperature of the order of 10 to the power 7 Kelvin. So for fusion reaction to take place, very high temperature of the order of 10 to the power 7 Kelvin is required. So the energy spectrum of beta particle emitted from the radioactive sources. Okay, option C is the right answer. As you know that the range of the energy of beta particles is from 0 to some maximum value. So 0 to some maximum value on the, that is the right answer, right graph. Next, the equation, whatever the equation they're given, you have to analysis and tell the particular equation for which it is for beta emission. Okay, since the atomic number increases. Since atomic number increases. So option 1. Next, the dependence of binding energy per nucleon Bn on the atomic number is represented by. So binding energy per nucleon is maximum for the atomic number. A is equal to 56. So option A, dependence of binding energy curve per nucleon. So for 56. Yep. Pi to the power ಅಂದ್ರೆ meson ಅಂತ ಹೇಳ್ತೀವಿ. At rest decays into 2 gamma rays. Then which of the following can happen? Which of the following can happen? The 2 gammas move in opposite direction according to the law of conservation of linear momentum. So according to law of conservation of linear momentum, the two gammas move in opposite direction. Which one is possible? So you have the law of leptons numbers ಅಂತ ಹೇಳ್ತೀವಿ. Mass number and atomic number is to be conserved on both the sides. Mass number and atomic number should be conserved on both the sides. So option C is the right answer. So mass number and atomic number should be equal. Okay. In which sequence the radioactive radiation are emitted in the following nuclear reaction? In following nuclear reaction. So you can say here the one by one. So X A Z gives rise to Y A Z plus 1. So since Z is been shifted to Z plus 1, you can say it is beta emission. Next, Y is equal to A Z plus 1. That implies Y is equal to A minus 4 Z minus 1. So decrease in A minus A is equal to 4. In decrease in A is Z is equal to, so from this you can say it is alpha particle. The next case, Y or K, A to the power 4 Z to the power minus 1, that implies it is going to remain same only. Okay, Y is equal to A to the power 4 Z minus 1, so it is going to remain same ಆಗಿರೋದ್ರಿಂದ it is gamma emission ಆಗುತ್ತೆ. So beta alpha and gamma, option D. ಸೊ ಇದೆಲ್ಲಾನು ಜನರಲ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಓದಿರ್ತೀರಾ ನಿಮ್ಮ ಥಿಯರಿಯಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯಲ್ಲಿ. ಓಕೆ, ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಎಮಿಷನ್ಸ್ಗೆ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲು, ಬೀಟಾ ಪಾರ್ಟಿಕಲು, ಗಾಮಾ ಪಾರ್ಟಿಕಲ್ ಯಾವ ಥರ ಡೆಫಿನೇಷನ್ಸ್ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಸಿ. Okay, the nucleus CD 11548 after two successive beta decay will give, after two successive beta decay it will give SN 11550. ಯಾಕಂದ್ರೆ the two successive beta decay increase the charge number by 2, increases by charge number 2. So 48 ಇರೋದು 50 ಆಗಬೇಕು. So ಅದು it remains same. So option 4. The ಮೇಲ್ಗಡೆ ಇರೋದು remains same. Okay. Next. Nuclear fusion is possible. Nuclear fusion is possible for only between light nuclei. Only between light nuclei. Option 1. The energy obtained when 1 mg mass is completely annihilated. So you have the formula E is equal to mc square. So m is equal to 1 mg, that is 1 into 10 to the power minus 6 kg. So C is 3 into 10 to the power 8 meter per second. So E is equal to 1 into 10 to the power minus 6 into 3 into 10 to the power 8 whole square. So it is 9 into 10 to the power 16 into 10 to the power minus 6. So it is 9 into 10 to the power 10 joules. So option B. Next, carbon dating is best suited for determining the age of the fossils if their age in years is of the order of. Okay, so as you know that it is order 10 to the 10,000 years. 10,000 years. This is because fossil older than this are destroyed due to the time factor. The tracks that are built by the rays are destroyed. The fossil earlier than this, the tracks are so small that it cannot be measured with accuracy. So the age of the fossil fear age in years is of the order 10 to the power 10 to the power 5. 10 to the power 5. Next, if 1 gram of hydrogen is converted into 0.993 gram of helium in the thermonuclear reaction, the energy released in the reaction is, so delta M is equal to 1 minus 0.993. So it is 0.007. So that is 7 into 10 to the power minus 6 kg. That is your delta M. So you have the formula E is equal to delta M C square. So 7 into 10 to the power 6 into 3 square andre 9 into 10 to the power 8. Correct? 3 into 10 to the power 8 the whole square. Sorry, into 2 andre 16. 9 into 10 to the power 16 and another 63 into 10 to the power 10 joules. So option C. Option 3. I hope you are clear. Next. The neutron makes a head-on collision with a stationary deuteron. The fractional energy loss of the neutron in the nucleus in the collision is, let m be the mass of neutron. Mass of neutron is 4m. According to the law of conservation of energy, momentum. According to the law of conservation of momentum, mv plus 0 is equal to head-on collision ಇಟ್ಟಾಗುತ್ತಷ್ಟೆ. mv1 plus 2mv2 ಯಾಕಂದ್ರೆ ಎನರ್ಜಿ ಅಂದ್ರೆ ಮಾಸ್ ಆಫ್ ಡ್ಯೂಟ್ರಾನ್ ಇಸ್ 4 times the mass of ನ್ಯೂಟ್ರಾನ್. ಕರೆಕ್ಟ್? ನ್ಯೂಟ್ರಾನ್ಗೆ ಎಮ್ ಅಂತ ತಗೊಂತೀನಿ, ಮಾಸ್ ಆಫ್ ನ್ಯೂಟ್ರಾನ್ಗೆ ಎಮ್ಮು, ಮಾಸ್ ಆಫ್ ಡ್ಯೂಟ್ರಾನ್ಗೆ 4m ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. 4m ಅಂತಂದ್ರೆ ಡಬಲ್ ಅಂತ ತಗೊಬೋದು. ಓಕೆ, ಅದಕ್ಕೆ 2 times ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. ಸೊ ಎಮ್ ಎಲ್ಲ ಕಾಮನ್ ತೆಗೆದ್ರೆ ವಿ ವೇರಿಯೇಷನ್ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ವಿ ಮೈನಸ್ 0 ಇಸ್ ಈಕ್ವಲ್ ಟು v2 plus v1. plus v1 ಇದನ್ನ ಚೇಂಜ್ ಮಾಡಿದಾಗ v2 is equal to v1 plus v. So according to the concept, relative velocity of approach is equal to relative velocity of separation. ಆ ಕಾನ್ಸೆಪ್ಟ್ ಬರುತ್ತೆ. ಸೊ ಅದು ಬಂದಾಗ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡೋದಷ್ಟೆ. ಅಂದ್ರೆ ಈ ಈಕ್ವೇಶನ್ ಹಂಗೆ ಇಟ್ಕೋ, ದಿಸ್ ಈಕ್ವೇಶನ್ ಇಸ್ ಹಂಗೆ ಇಟ್ಕೋ 1 ಅಂತ. ಈಗ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಯಾವುದು ರಿಲೇಟಿವ್ ವೆಲಾಸಿಟಿ ಆಫ್ ಅಪ್ರೋಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ರಿಲೇಟಿವ್ ವೆಲಾಸಿಟಿ ಆಫ್ ಸಪರೇಷನ್. ಆ ಕಾನ್ಸೆಪ್ಟ್ ಪ್ರಕಾರ ವಿ ಮೈನಸ್ 0 ಇಸ್ ಈಕ್ವಲ್ ಟು ಇನಿಷಿಯಲ್ 0 v2 plus v1. ಸೊ v2 is equal to v1 plus v. v2 ಜಾಗದಲ್ಲಿ ಈಕ್ವೇಶನ್ 1 ಅನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲೇನು ಉಳ್ಕೊಂತು ನನಗೆ mv is equal to mv1 plus 2mv1 plus 2mv ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಬರ್ತಿದ್ದೀನಿ. ಸೊ ಆಗಿದು 3mv1 plus 2mv. So 3mv1 is equal to mv v divided by v1 is equal to 3 divided by 1. ಸೊ ಎರಡು ಕಡೆ ಸ್ಕ್ವೈರಿಂಗ್ ಮಾಡ್ತೀನಿ. v square divided by v1 square is equal to 9 by 1. ಸೊ ಎರಡು ಕಡೆಗೆ ಏನು ಮಲ್ಟಿಪ್ಲೈ ಅಂಡ್ ಡಿವೈಡ್ ಬೈ half m. So half m v square divided by half m v1 square is equal to 9 by 1. So our fractional ratio ಅಂತಂದ್ರೆ ಬಿಟ್ಟ. So 9 1 by ಸೊ ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಸೊ ಇಲ್ಲಿ ತಗೊಂಡಾಗ the thing is finally you can take it as v1. ಸೊ ಫ್ರಾಕ್ಷನ್ ಅಂದರೆ ಇದನ್ನು ಉಲ್ಟಾ ಮಾಡಿದ್ರೆ ಓಕೆ ಫೈನಲಿ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ 1 minus 1 by 9 ದ ರೇಷಿಯೋ ತಗೊಂಡಾಗ ಓವರ್ ಆಲ್. ಓಕೆ ಸೊ ಇದು ಜನರಲ್ ಆಗಿ ಹೇಗೆ ಬರುತ್ತೆ ಅಂದರೆ ಯು ಹ್ಯಾವ್ ದ ಈಕ್ವೇಶನ್ ಫರ್ದರ್ ಅಂದರೆ ಇಲ್ಲಿ ನಾವು ಏನು ಜನರಲ್ ಆಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಈ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಒನ್ ಹಾಫ್ ಎಮ್ನ ಮಲ್ಟಿಪ್ಲೈ ಆ್ಯಂಡ್ ಡಿವೈಡ್ ಮಾಡಿಕೊಂಡು ಸೊ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ V1/V2 ಫ್ರಾಕ್ಷನಲ್ ರೇಷಿಯೋ ಆಫ್ ನ್ಯೂಟ್ರಾನ್ ತಗೊಂಡಾಗ V1/V2 ತಗೊಂಡಾಗ ರೇಷಿಯೋ 1/9 ಬರುತ್ತೆ. ದ ಫ್ರಾಕ್ಷನಲ್ ಎನರ್ಜಿ ಲಾಸ್ ಅಂತ ಅಂದರೆ ಓವರ್ ಸೊ 1 - 1/9 ತೊಗೊಂಡು ಸಾಲ್ವ್ ಮಾಡಿದಾಗ you will be getting 8/9. 8/9. Clear? The amount of so I hope you are clear with that. Okay, so ಇಲ್ಲ ಇನ್ನೊಂದು ಥರ ಮೆಥಡು ಮಾಡ್ಬೋದು. The another method is like it is ಸ್ವಲ್ಪ lengthy. So according to the law of conservation of energy, ನೋಡಿ I'll do that. One more thing. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. ಇದು law of conservation. So ಈಗ head-on collision ಅಲ್ಲಿ you can say kinetic energy is also conserved. Okay, kinetic energy also is conserved ಬಂದಾಗ you can write half M1 U1 square, correct, plus half M2 U2 square is equal to half M1 V1 square plus half M2 V2 square. So ಎರಡು ಈಕ್ವೇಶನ್ ಇಟ್ಕೊಂಡು ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಯು ವಿಲ್ ಗೆಟ್ ದ ಟೂ ಈಕ್ವೇಶನ್ಸ್ ಬರುತ್ತೆ. ಯಾವುದು V1 ಮತ್ತು V2 ಬರುತ್ತೆ. ಓಕೆ, ಆವಾಗ ಇದೇನು ಅಂದರೆ ಫಸ್ಟ್ ಇಯರಲ್ಲಿ ಯು ಹ್ಯಾಡ್ ಒನ್ ಡಿರೈವೇಶನ್ ಇದೆ ಅಲ್ಲಿ. ಅವಾಗ ನೀವು ಮಾಡಿದಾಗ ಯು ವಿಲ್ ಗೆಟ್ V1 is equal to M1 minus M2 divided by M1 plus M2 into U1 plus 2M2 divided by M1 plus M2 into U2. ಓಕೆ, ಸೊ ಅದನ್ನೆಲ್ಲ ಸಾಲ್ವ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ದ ವೆಲಾಸಿಟಿ ಆಫ್ ನ್ಯೂಟ್ರಾನ್ ಅಂದರೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಆಗಿ ತೊಗೊಂಡಾಗ ಮಾಸ್ ಆಫ್ ನ್ಯೂಟ್ರಾನ್ ಇಸ್ ಟ್ವೈಸ್ ದ ಮಾಸ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಆಗಿರೋದ್ರಿಂದ ಇದು V1 ಅಂತ ಇಟ್ಕೋ. ನೆಕ್ಸ್ಟ್ V2 is equal to M2 minus M1 divided by M1 plus M2 into U2 plus 2M2 by ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ. U2 U1 ಇದು. ಸೊ ಈ ಥರ ಅಲ್ಲಿ ಈಕ್ವೇಶನ್ ಬಂದಿರ್ತು ನಿಮಗೆ. ಸೊ ಈಗ ಫೈನಲ್ ಆಗಿ ದ ವೆಲಾಸಿಟಿ ಆಫ್ ನ್ಯೂಟ್ರಾನ್ ಅಂತ ತಗೊಂಡಾಗ ಆಯಿತಾ, ವೆಲಾಸಿಟಿ ಆಫ್ ನ್ಯೂಟ್ರಾನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದೇ ಗಿವನ್ ಯು ಆ ವ್ಯಾಲ್ಯೂಸ್ ಎಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀರಾ. M1 is M, M2 is 2M, ಕರೆಕ್ಟಾ, ಟ್ವೈಸ್. ಸೊ ಡ್ಯೂ ಟು ಅಂದರೆ ಟ್ವೈಸ್ ದಟ್ ಪಾರ್ಟ್ ಮಾಸ್ ವಿಲ್ ಬಿ ಟ್ವೈಸ್ ಆಗಿರುತ್ತೆ. ಅವಾಗ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಇಟ್ ಆಸ್ ಓಕೆ. ಸೊ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಫ್ರಾಕ್ಷನಲ್ ಎನರ್ಜಿ ಅಂತ ಬಂದಾಗ 1/mu ಸ್ಕ್ವಯರ್ ಮೈನಸ್ 1/2m minus u divided by 3 the whole divided by half mu square. ಇವನ್ನೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ 1 minus 1 by 9 ಬರುತ್ತೆ. ದಟ್ ಗಿವ್ಸ್ ಯು 8 by 9. ಸೊ ಅಂದರೆ ಇದು ಬೇಸ್ಡ್ ಆನ್ ದ ಫಸ್ಟ್ ಇಯರ್ ಡಿರೈವೇಷನ್ನಲ್ಲಿ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬೇಕು. ಓಕೆ, ಐ ಹೋಪ್ ಯು ಆರ್ ಕ್ಲಿಯರ್ ವಿತ್ ದ್ಯಾಟ್. Okay, next, the amount of radioactivity. The amount of active substance reduces to 1 by 64 of its initial value in 15 hours. What is the half-life? Half-life ಅಂತ ಇದೆ. Okay. In that case, you have the formula n by n naught is equal to half t by t. So that is nothing but 1 by 64 is equal to, this is the formula, so half of 15 by t. So ಇದನ್ನ ಏನು ಬರಿಬೋದು, 1 by 2 in terms of ಅಲ್ಲಿ ಬರೆದು 6 2 to the 4 4 to the 8 8 to the 16 4 ಆಗುತ್ತೆ. ಕರೆಕ್ಟ್. ಸೊ 6 ಟೈಮ್ಸ್ ಮಾಡಿದಾಗ 64 ಬರುತ್ತೆ. ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಹಾಫ್ 15 by t. ಬೇಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದ ಮೇಲ್ಗಡೆ ಟರ್ಮು ಈಕ್ವೇಟ್ ಮಾಡ್ತೀವಿ. ಸೊ 15 by t is equal to 6. So t is equal to 15 by 6 is 2.5 hours ಆಗುತ್ತೆ. So option A. Okay. So I hope you understood about today's class, right? So we have some more numericals based on the nuclei. So we'll be discussing that in the next class. Thank you all. Have a great day.